So we want to find the limit as n goes to infinity of a sub n, which is the limit as n goes to infinity of n to the 1 over n, which will be equal to the limit as x goes to infinity of x to the 1 over x. Okay? So you're going to have to let y equal the limit as x goes to infinity of x to the 1 over x. Then you're going to do the natural log of each side, and we can streamline it. I'm going to do one more step for you. I'm going to let you take off with it. ln y, you can just put the natural log on the inside. We don't have to write out that extra step. Okay? So now you can bring this down, rearrange it so it's set up for L'Hopital's rule. Give it a try. All right, you guys all right up to there? Any questions up to there? So now we use L'Hopital's rule. The derivative of natural log x is 1 over x. The derivative of x is 1. So this is the limit as x goes to infinity of 1 over x, which is 0. But that is not finished. What equals 0? Yeah. This all started out here. ln y is equal to 0, right? Exponentiate. What do you get? E to the 0 equals y, right? Anything to the 0 power is? So y equals 1. This limit is 1. Let's check it here. Got the answer. Yep, it's correct. This limit here, the limit of n to the 1 over n power as n goes to infinity is 1. So that one did work out kind of intuitively, didn't it? Because this is going to 0, 1 over infinity, that's 0. this is 1, and multiply, well, 1 to the 0 is 1. So that one did work out intuitively, but they do not always work out intuitively. All right, any questions? This process is going to come up occasionally in this chapter. Okay, we will see it some more. All right. Let's say that. I think the last two problems involve something I want to show you next. See if I can get through this off the top of my head here. We have a sub n equals negative e to the negative 3n. Cosine. We know that the answer is going to be 0. All right, so if we want to find the limit of this, the limit as n goes to infinity of negative e to the negative 3n cosine n, well, that could be written as negative 1 over e to the 3n cosine n, correct? Now, cosine. Cosine bounces around between what numbers?
0 and 7.
Can cosine be negative?
Yes.
Yeah, the cosine graph, y equals cosine x. Doesn't that do this forever in both directions? And this is 1 and this is negative 1, right? So the cosine values jump between 1 and negative 1. They're going to take on values between negative 1 and negative 1. Sometimes they're negative, sometimes they're positive, right? Okay, so that piece is always between 1 and negative 1. So does that mean that this expression, I can put negative 1 over e to the 3 in here, less than or equal to cosine n less than or equal to positive 1 over e to the 3n? Is that true? Because when cosine is negative, negative times this will be positive. When cosine is positive, positive times this will be negative. But cosine never gets less than negative 1, never gets greater than 1. So Do you agree with that? Let me make sure if I'm supposed to stick this is true, but I think we can also put, let me double check so I don't do this wrong. We're gonna go after this example. Well, let's put the negative 1 over e to the 3n here. I don't know if I like that there. Let's take it out. I don't like it there. My point is, cosine has to be between these. What's this approaching as n goes to infinity?
0.
0. What's that approaching?
0.
So this is approaching 0 from the negative side. We do need it in between there, I'm sorry. E to the 3n. Because cosine is going to either be 1 or a decimal number less than 1, when it multiplies by this, I'm sorry, I gotta rethink this. The point is, this goes to 0 from the negative side, that goes to 0 from the positive side, and this is getting squoze in between. Does that make sense? And it's gonna force this to go to 0. That's the point here. And so the limit here is gonna be 0. Now, got my head a little confused. Let's see, v sub n. They don't show it exactly like this in here. Yeah. Use a negative sign. Trapped between those. This is trapped between these guys, and since these are each going to 0, this has to go to 0. And so this limit here is going to equal 0. And we call that squeeze theorem. All right, yes, sir?
Would we do that anytime there's a cosine or sine in the problem?
And you have 1 over something going to infinity, yes. You know, this is going to infinity down here. So, yes.
So basically, we kind of apply what we learned from Calc 1 to squeeze theorem?
Yes, this is squeeze theorem from Calc 1. Yes. All right. That does finish the section. Monday, I might clean this up a little bit because I planned for section 10.3 today. I'm going to do geometric series. We'll do that on Monday. I might clean this up a little bit, because I was teaching on top of my head here right now. Have a great weekend, and we'll see you on Monday. I do need to fix attendance. Pedro? Oscar Castellanos? Andrew? Here.